Hey everyone, so for this video I am going to go over some review with you guys from chapter 12, and I'm only going to focus on sections 1 and 2 for this video, and I will be making an additional one to go over sections 3 and 4. So in section 1, this is when we first started talking about square roots for the first time, and we kind of went back and forth with writing something that was already in a square root form so that it had an exponential exponent, and then we talked about going the other way. So if it had an exponent, how to write it in radical form, and kind of vice versa. The main thing that I want you guys to remember to do from section 1 is if they give you a problem that says to write the root in radical form and in exponential form, if they actually have it written out in words, I want to make sure that you know how to write it in square root form or cube root form or whatever it is, and then also with the rational exponent. So if they say the square root of 49, then hopefully you guys can see this square root of 49 right here. The square root of 49 just looks like that, but then as a exponential form, it would be 49 to the 1/2 power. The square root is always the 1 over the 2. We talked in class about how there's technically like a little 2 sitting right here in that square root, and that's what always goes in the bottom of your fraction. So for the cube root of 125, we would do the cubed root, 125 underneath there, and then the exponential form would be 125 to that 1/3 power. Going into section 2, we were able to convert radicals back and forth again, still like going from radical form to exponential form, but also then writing it in simplest form, so being able to simplify the fractions if you need to. Again, if you just saw something that looked like number 1 where it has the cube root of x, I would just want to see you guys write that as x to the 1/3 power. Now the second one, you've got the cube root, and then underneath the radical sign you have 8 and then b to the 12th power. So the cubed root of 8, if you were to evaluate that, would be the 2 that I have written here. And then how I got this 4 is, again, you take the 12 underneath and you divide by the number out here in the corner, which is that 3. So that's how I got 4, because 12 divided by 3 would be 4. So it would be 2b to the 4th power. Now, the third one on this page is a little more detailed in what they want you to do. So we've got all of this underneath the square root sign, but then it's also raised to the 4th power. So the first thing I would do is work with that square root portion. The 49 is a perfect square number, so you don't need to worry about that one. And with these letters, you just want them to have even exponents. So like the first one has a 2, which is even, but the y has a 3. So what I did down here is I actually broke y apart into y squared times y, so that when I square root 49, I get 7, and the square root of x squared and y squared is x and y. You're just, again, dividing those by this time a 2, because there's a 2 sitting there. Now that other y will just have to stay underneath the radical sign. So now all of this is raised to the 4th power. So 7 to the 4th power is how I got 2,401. And then x to the 4th, y to the 4th. Now that portion that's still underneath the radical sign, rewriting that so that it's with an exponential form, it's y to the 1/2. And then that's also raised to the 4th power. So when you guys have an exponent raised to another exponent, remember you have to multiply those. So you're taking 1/2 times 4, which is 2. And then when you have y to the 4th here, and then this became y squared, you add those. And so that's why my final answer has a y to the 6th power. Another thing that we did in section 2 was being able to combine the exponents if they have the same base. So if you have both items have a's, or both items have x's or y's, or whatever the letter might be, or it could even just be numbers, as long as they have the same base, you can combine their exponents. Now when you're multiplying them, the rule is to add your exponents. When you're dividing, the rule is to subtract the exponents. So for this first one, a to the 1/2 times a to the 3/2, we add those fractions. So 1/2 plus 3/2, which would technically be 4 over 2, which reduces to 2. So that's why I got a squared. For the second one, I subtract my exponent, so you can see I have 1/6 minus 5/6. Now that's going to give me a negative 4 over 6 here. So then I can reduce that to negative 2/3, but we talked about how you cannot have negative exponents, so you have to drop that whole quantity down to the bottom of the fraction. So we just put a 1 on top over that x to the 2/3 power. So that is the end of that review. I will be posting a video for the second two sections, but I'm also going to give you guys just some problems to work on for just these two sections to kind of get you guys back into this thinking. Let me know if you guys have any questions. Feel free to send me an email.